Hello and welcome to my very first tutorial. My name's Matt Taylor and we're going to be learning how to make these Mondrian-esque slidey grid things in Houdini using VEX. It's probably best if you've at least got the basics of Houdini down before you do this, and if you've used VEX before, that's going to be really helpful. Right, so let's get started. We'll hop into Photoshop first to explain the theory a little bit. So we're going to start with a polygon that has 4 points, like so. And in Houdini, those points are going to be numbered 0, 1, 3, and 2. Now, what we want to do is make 4 new points that exist between these ones to divide the polygon. And those are going to be just here like this. There we go. And those points are going to be named A, B, C, and D. Now we're going to use these points to make 2 new ones that exist within the polygon. One here and one here. And we're going to name these E and F. So points E and F are going to exist between point B and point D. But point E is going to be in line with A, and point F is going to be in line with C. Now when we connect these polygons, like so, we're subdividing the polygon into 4 new ones. 1, 2, 3, and 4. Now, we're going to drive the positions of these divisions by moving points A, B, C, and D around, basically between the points that already exist. We're going to do this with a random noise and a function in VEX called lerp. But I'll explain that when we get into Houdini. What we're going to do then is we're going to take the entire system and kind of put it back into itself so that these polygons are then divided even further, each one of them getting a sort of slightly different division, just like that. Okay, so let's hop into Houdini and build it. So the first thing we need is a geometry node, and we'll dive inside, and then we need a grid. So the grid is going to be set to 2 by 2, and then if we just switch points and point numbering on and orient this so it's like our diagram, you can see point 0, 1, 3, and 2. Okay, so the next thing is to make a not a point wrangle, but a primitive wrangle. Okay, and we're just going to pop out the editor. So the first thing we need to do is make a couple of variables for X and Y, and these are just going to store the noise function that kind of animates everything. But before we attach it to the noise, I'm just going to set them up so that they're on channels, so that we can just play around with them while we build everything and just make sure everything's okay. So we need one for X, and then we need one for Y, like so. Okay, so the next thing is we need to take all of our points on the primitive and we need to store them inside an array so that we can access their values. So to do that, we're going to make a new array called points, and that is going to equal prim points 0 and prim num. So now we're taking all of these points and we're storing them in an array so that we can kind of access their positional data. So then we need somewhere to put that positional data. So we need vector called parse 0. I'm going to use an underscore there. Parse 1, parse 2, and parse 3. So these variables that we've made are going to store the positions of each of the 4 points. So let's do that next. So pos 0 is going to equal point 0 p and point 0 is PNTS 0, so it's position 0 in the array. Okay, and then we're going to take this and make a copy for each one. So position 1 is going to be position 1. Position 2 is going to be point 2. Position 3 is going to be point 3. All right. The thing we need to do next is start creating the points that exist between these ones, and we're going to have to store values for their positions first. So I make vector pos A, which is going to store position A, and I'm just going to copy and paste this to make it easier. I need position A, B, C, D, E, and F. So let's just change them. B, C, D, E, and F. Now, if you remember from our diagram before, position A needs to go between 0 and 1, and we're going to drive it with our y value because this is the y-axis. I mean, I think actually in Houdini it's the x-axis, but for the purpose of thinking of this like a graph, this is going to be the y-axis. So, and to do this, we're going to use the lerp function. So how this works is it performs bilinear interpolation between values. Okay, so we enter value 1, which in our case is going to be the position of point 0, and then value 2, which is going to be the position of point 1, and then our float amount, which is going to be the value y. And then based on the value y, we're going to interpolate between these two values. So let's copy this and bring it into Houdini. So if we say pos A equals lerp, so this is pos 0, pos 1, and then the amount is y, like so. Now, before I do the rest of these, what I'm going to do is just add the point, add point 0 and pos A, and just so that you can see how this works. So there's something wrong with this. Oh, no, there isn't. Okay, so you can see how it works. So we've added a point, which is being numbered number 4 here, but this is point A. And when we slide this y-axis, you can see it moves up and down. Okay. So the next one is going to be pos B. And if you remember that B exists between 1 and 3. So if we take this, and it's driven by x, so position 1 and position 3 and x. Now you're going to see one of the problems that we're going to come up against. I've forgotten to add the point. B. Okay, so now you see we have a problem because point B isn't sliding between 1 and 3. Now, what's happening here is, although Houdini is naming the points 0, 1, 3, and 2, when you actually use the prim points function, it's taking into account the vertex winding when it sorts this array. So to fix this problem, we have to imagine that the points are actually ordered in a clockwise direction. So it goes 0, 1, 2, 3, which makes a lot more sense, I think, than the way Houdini builds the grid initially. So if we change this 3 to a 2, and from now on we just kind of think of point 3 as being point 2 and point 2 as being point 3, everything works. So if we drag this along, you can see that that works fine. So the next one is going to be position C. Position C is between 3 and 2, or between 2 and 3, but actually also it's going to be reversed. We want this one to work in the opposite direction. I'll show you what I mean. So first is going to be this, which is position 3, and then position 2, that's correct, and it's on the Y. There we go. And you see, I just need to add the point, like this. And you can see that they move together now. But I want this to be reversed. So what I'm going to do is, instead of it being Y, I'm going to say it's 1 minus Y. And then you see that they work now in opposite directions. And that's what we're after. Okay, and then the last one here to make is, it's not quite the last one, is point D. So point D is going to go between 0 and point 2, which is point 3. So this is 0 and 3, and it's going to be on the x-axis, like this. And then let's add the point, like that. D, excellent. And then you can see that that all now works correctly. Now, we need to make point E, which is one of the central ones. So if you remember, point E is going to be between B and D, but it's going to be in line with point A. So point A is the value of x away from 0. So that's what we're going to do. So we're going to place it between D and B using x, and that will give us the position. So if we go point D and B using x, and then just let's make the point E. And you see, there we go. So, oh, we have a problem. I'm going to figure this out and come back to you. And of course, the problem is that it's not x, it's actually y. So you can see that that works now. It sits between point B and D and is in line with point A. And then the final point here is point F, and point F is again between D and B. To be in line with point C, we have to use the same trick that we used with point C, so we need to make it 1 minus Y. There we go. Let's copy that and put that there, so that's F. So there we go, we have everything connected correctly. And it all seems to be working. Excellent. All right, so the next thing that we need to do is, I'm just going to tidy up a little bit here. The next thing we need to do is connect all the polygons together. And to do this, we're going to use, connect all the points together, into polygons. And to do this, we're going to use add prim. So add prim takes the gear handle and then the string type, which is going to be polygon. And we're going to take these, we're going to use this one because it lets you add 4 points to make a rectangle. Now, if you can see, what it expects is an integer. And if we go back to Houdini, we don't really have any integers for these points. We have the positions for them. So we need to just put these into variables. So if we go point A equals, int point A equals. So now we've just stored the point into an integer that we can work with. So I'm just going to copy this and paste it for each one, like so. B, C, D, E, and F. And now we're going to take add prim 0 poly. The first one we're going to make is going to be this one on the bottom left corner, and it starts with point 0, and then point 4, or point A, sorry, and point E, and then point D. So point 0, if you remember points we stored in the points array at position 0, and then we need PNT A, PNT E, and then PNT D. There we go. And then if you look, we've created this polygon. So now we just need to make the rest of them. So, and what I'm doing here is I'm starting in the bottom left corner and kind of going around the clockwise direction. This is so that the normals work in the correct direction. So this one we're going to start with point 4, and then go around this way, and then this one we're going to start point A, and then with this one we're going to start with point E and go around. Oh well, actually not E, it's actually F. We're going to start with F and go around, and then this one we're going to start with point D. Although I think when I did this the first time, I got slightly more interesting results if I started one of the polygons on a different number. So perhaps this third one that we do, I'm going to start on point B. Okay, so let's just copy that. So the next one is going to be point A, and then it's going to be point 1, and then point B, and finally point E. So we've made another one here. If I just turn on the normals, you can see that they point in the right direction. If you wind them the other way, if you went anti-clockwise, you end up with a normal that points in the wrong direction, and that's bad and difficult to fix when you subdivide this and you end up with thousands of polygons. Okay, so the next one we need to do, and this is the one I'm going to wind not in a different direction, but I'm going to start in a different corner. So I'm going to start with point B. So point B, and then this is PNTS 01. Well, if you remember, we used 2 instead of 3. And then this, which is point C, and then finally point F, like that. There we go. And then last one. So last one is point D, and point F, point C, and let's just think, so it's PTS 3, that's right. Yeah, okay, so there we go. So now when we slide the sliders, you can see everything works correctly. And the final thing to do here is just to remove the original primitive. We've made these new primitives kind of on top of it, but we don't need the original square. So we're going to just remove it, and it's geometry stream 0, and it's at primnum. There we go. Oh, and actually remove prim needs an extra variable just to say whether you are keeping the points or deleting them. So there we go. In our case, it wouldn't matter. It only takes into account points that are already connected. Okay, so there we go. Okay, so the next thing we need to do is go build a loop, so we have a for each number. So we want to fetch feedback, and we're going to do it by count, and we're going to feed back each iteration. Okay, and we don't want to go 10 iterations, it's probably too many. Start with 4. And we just plug this into here. There we go, and there we go. So you can see we're getting kind of almost a desired result when we slide these around. It's really interesting. And the next thing to do is to get these controlled by a noise rather than these sliders. And these sliders are applying the same value to each iteration, but we want a noise that's based on its position in space, and that makes the result far more interesting. So the first thing we need is a float time. And then we need a seed for the noise. So seed, whoops, seed, and then we just need to modify this to be a flow noise. I'm using flow noise so that we can get the noise to loop. So what this expects is the position of each primitive, and then we're going to plus the seed here. That's going to let us vary it a little bit, and then the flow value is going to be time, and let's times that by 2. Excellent. Okay, and then let's do the same here. So y, instead of plus the seed, we're going to minus the seed, and let's just time plus 0.5. Let's make it a little bit more varied. Cool. And now if we just get these extra channels, you'll see we have the seed, which we can move to something interesting. And as we move the time, you can see it moves around, and actually it loops. So if we go between 0 and 1, you can see that they're exactly the same, which is why we're using a flow noise here. I think the result right now isn't very interesting. So what we want to do is maybe modulate the noise a little bit with a ramp. Okay, so how we do that? Well, first we're going to animate it. So if we just keyframe 0 and then maybe on 120 to 1, let's just go to the animation editor and just make this linear. There we go. And then 120. So if we hit play, we can see we have this moving around. It's just conform to real time. There we go. And that's looking good. Okay. So the next thing is just to mess around with these a little bit. So we say x equals fit. Okay. And it's going to be x and then 0.1, 0.9, and maybe then just go 0.01 to 0.99. And that is going to make sure that we can never go to a value of 0 and we can never go to a value of 1, and we're just taking a little bit out of the noise. We're just kind of clamping the noise a little bit. So that's good, and then we'll copy this for y. So y equals, that's good, excellent. And then maybe we want to just ramp them a little bit. So if we go x equals ramp, and it's going to be x ramp and x. There we go. And just again do the same for y. perfect. And then let's just go down here and just sort these out. So we probably want to take oops, Bezier, something like this, and the same here. So Bezier, and then when this animates, you see that the animation is a lot smoother. I'm just going to turn down the iterations. So there we go. And yeah, it's a little bit fast, but you can we can slow it down just by kind of changing this the seed value to a kind of lower value, and that's quite a nice result. And if we go into here and just up the subdivisions, you can see it's really interesting. Okay, and that is kind of it really. I think the only other thing that I did when it came to the first animation that I put up online was I put the whole thing in a bend to just kind of wrap it around a cylinder. So if we the bend angle to minus 360, and we just change the capture origin, whoops, on Z, and the capture length like that. So it's like -5 and the capture length 10. And then I think just before the bend we did a subdivide. And there we go. And you can see, there we go. And you can see that, yeah, that's how we build it. So that's about it. Thanks for watching. If there's any questions you've got, feel free to leave me a comment. And if there's any other tutorials people want to see, you can kind of get me on Instagram. Just send me a message and I'll think about making them. Thanks very much, and goodbye.